vocabulary. So the first part is going to be radicals. And so I'm going over questions on this blue sheet, or I'm going over different types of questions. On this blue sheet is your review sheet. This is a humongous packet, right? You're probably not going to look over 58 pages of problems to study. Instead, I want you to write down anything that you want to remember. So like if you remember radicals, then don't write it down. But on this blue sheet, this is your study guide, so write your name at the top. And anything you want to remember or any type of problems, that's what you're going to write down. So like you can color code it. I can give you as much color paper as you want. But that's for you to be able to look at one sheet as opposed to 58. So the first thing we're going to go over is radicals. And so some of you guys did it yesterday. Most of you were testing. So we need to know how to simplify radicals, add, and subtract radicals. And so these are the three things we're going over. I'm going to start with just like three. Oh, I need to calibrate this first. Cool. Let's start with 3 radical 20. How do we simplify that? Because these are going to be non-calculator questions. So you are going to need to know how to simplify by hand. Does anyone remember, like, how do we break down 20? Sure, 10 and 2. If Betsy really wanted to use 5 and 4, would that still be correct? Yeah, she would still end up with the same numbers at the end. Boys, put your phones away. Are any of those prime? 2, so we circle it. What goes into 10? 5 and 2. Are those prime? So we circle them. So remember the prom example? Who's already at prom? 3. So we put 3 over here. Then remember, people can only go to prom if they're compatible. They're the same number. And only 2 per prom date. Is there anyone going to prom out of these 3? The 2s. Look how cute they are. And it's 1, 2 per couple. Who's staying home crying because they don't have a date? 5. And so what's my answer? 6 radical 5. So make sure if you don't remember how to do this, I know a lot of you know how to use it in your calculator, but most likely this is going to be a non-calculator part of your test. I am going to be going pretty fast because make sure you do that homework so you can see what you know, what you don't know. You also need to know multiplying and adding. So let's go through this one next. 3 radical 3 minus 2 radical 27. That's my next example. So first, all I do is simplify each one. Can I simplify this one? Can I break down 3? No, because it's just 3 and 1. It's prime. Can I break down 27? Yeah, so let's break this one down. What goes into 27? 2 numbers multiplied by 20. 3 and 9. Are any of those prime? 3. What multiplies to 9? 3 and 3. Are any of those prime? Both of them, right? So who's already at prom? -2. Who's joining -2? These can all 3 of them go to prom together? Nope, only 1 per date. Then who's staying home crying? Sister. So my answer right here would be, I'm going to write it right over here, -6 radical 3rd. And then I move this first one back over like that. I only can add and subtract if they have the same radical, the same guy in the house. So now I just subtract these 2 numbers. What's 3 minus 6? -3. Do I subtract the radicals? I guarantee that the 0 will be an answer choice on your milestone. We keep the guy in the house. So this would be your answer. Does that make sense? So we don't add the guy in the radical or subtract it. I guarantee that 0 will be an answer choice. Does that make sense? And if you guys all know how to type it in your calculator, there's only 10 non-calculator questions. They're mostly going to come from this unit. Does this make sense? All right, last one's multiplying. So I'm just going to scroll down. multiply is easy. All it is, let's do like 2 radical 5 times radical. When we multiply, all we do is multiply the outsides. What's the invisible coefficient right here? 1. So we do 2 times 1. What's 2 times 1? 2. Then we do 5 times 8. 40. So see, when we multiply, we can multiply the outsides and insides. And then we just simplify. What multiplies to 40? Sure. 2 and 20. Are any of those prime? 2. What multiplies to 20? 10 and 2. 2's prime. What goes into 10? 5 and 2. So who's already at prom? This 2 right here. Who's joining 2? These 2, right? And then who's staying home crying? 2 and 5. And so what's my answer going to be? What's 2 times 2? 4. Radical 10. Cool. This is like a whole unit in like 30 minutes. Do y'all want to practice with radicals just to make sure you got it? Okay, so if you go to page 5, this was your homework. So page 5, these 2 problems were your homework right here. Try them out. See if you can do numbers 1 and 2. It's on page 5. So if you didn't number them, at least number to page 5 so you know where that is. I'll give you a few minutes. So most likely the questions will look something like that. The next ones we're going to go over is rational and irrational. All right, what 2 answers did you end up getting? What did you get for the first one? A. Good. A was the first one. What was the second one? C. So if that is something you can't do by hand, or you don't know how to do it, make sure to star it so that like when we do have practice later on, that those are the type of problems I'll give you. All right, next one's rational and irrational. If you don't remember what that is, write it in your blue sheet. If I said that someone's being irrational, like, well, that would mean like they're talking forever and ever. You know, those people that don't make sense and they just keep talking. Those are irrational people, right? So irrational number is a number that can't turn into a fraction and it just goes on. It's a non-terminating decimal. So how you can tell in your calculator too is if you click that little button that looks like this on your answer and it can't turn into a fraction, there's no fraction, then you know it's irrational. You also know if there's a radical in your answer, that it's irrational. Rational numbers are people short to the point. So rational means like short to the point, a terminating decimal. So when we look over here, it says which sum is rational. So I want you guys to try to figure out, okay, which one would be rational, which means it's terminating decimal, short to the point. Which one do you think it would be? So start typing them in your calculator. Do you all know where pi is in your calculator? Okay, so type each of these in and figure out which one would be rational, which rational means a decimal that's terminating, which means it stops. So like 2.75 would be terminating decimal. If it goes on all the way to the edge of your calculator, you know it's a non. So which one do you think would be rational? And so that's why I make sure you do your homework, especially like tonight, because these problems were on there. So that way we can just go through and figure out, okay, what do you know? What do you not know? Because we did squeeze an entire year of Algebra 1 in one semester.
B.
It is B. Does everyone get why it's B? What's the square root of 25? 5 plus 1.75 is just 6.75. If you have pi in the answer, it's going to be irrational. Pi is a number that goes on forever and ever and ever. Is that a perfect square or a non-perfect square? Radical 3. Well, If you put radical 3 in your calculator, it would be a decimal that goes on forever. And if I just add 5.5 to it, it's not making it rational. So my answer would be B. Now try number 4. Which product is irrational? So which one is going on forever and ever or not making sense? Figure out which decimal would be irrational. Y'all get the answer? Which one is it? D. Because let's look at it. What's 2 times 50? 100. What's the square root of 100? 10. That's rational. That's 10.0. What's the square root of 64? The square root of 64. 8. What's the square root of 4? 2. What's 8 times 2? 16. That's rational. What's the square root of 9? Remember, it just means what times itself equals 9? 3. And what times itself equals 49? 7. And we know that equals 21. When we do this, it ends up being square root of 80, and that is not a perfect square. So that would give me an irrational answer. If you end up with a radical in your calculator still, you know it's irrational. Does that make sense? Yes? No? So make sure to star the ones that you maybe want extra practice on, but like we're going to keep
I have a question. Is convert?
I'm going to do that last though. So we're going to skip to the next page. So go to the next page, turn it over, and we're going to go through polynomials first. And so again, make sure you're writing any notes that you need to write down. So I'm going to be writing answers and stuff on here, but if there are certain things you need to remember, like vocabulary, make sure you write it on that blue sheet so you don't need to fill through this big yellow packet. Okay, so the first thing I want to do is look at area versus perimeter. What does perimeter mean? Because remember, that's on it a lot. What does perimeter mean? How would I find it? Add all the sides, right? So I know that perimeter is adding all the sides. If you don't remember that, write that on your blue sheet. I guarantee that they'll have one like this, and they'll have the answer as 8x plus 10. Remember, if this side is 5x plus 2, what's this side? This side's 5x plus 2. What's this side going to be? 5x plus 2. If this side is 3x plus 8, what's this side going to be? Yep. And then we're just combining our like terms. So we're writing down all our terms. So 3x plus 8. And you don't have to write them all down like this. I'm just showing you what you need. Most people can do it in their head if they want. So now we combine all our x's. So which ones have x's in it? 3, 5, 3, and 5. What do you end up getting?
16.
Yep, 16x. Then I add 8 plus 2 plus 8 plus 2.
20.
20. That's your answer. This is all from Unit 1. Cool. Make sure you write that down if you on the blue sheet if you need it. If you don't, then you don't need to write it down on the blue sheet. Subtracting polynomials. So this would be in the same box, adding and subtracting polynomials. So I'm actually gonna I'll put it right. I'm gonna be writing in this area, but it's just for this one. So I have x to the third plus 2x minus x. What do I do when I'm subtracting polynomials? Distribute what? The negative one, right? So remember, you have to put that invisible one right there. Remember this? If you didn't remember, write that down. It's not going to pop in your head all of a sudden. So if you don't remember that, write it down. We put that invisible one. What does that do to all three of these signs? It changes it. It flips it. So this is going to change to a what? Positive 1x squared, or to the third. What's this going to change to? And that. Good. So the second parentheses all changes signs. Does the first one change signs? This one?
Oh, yes.
Not the first one. We just rewrite the first one. So we rewrite the first one and then change all the signs when we're subtracting. Then what do we do? Add like terms. So we'll start with this, the highest exponent. What's the vocabulary word for highest exponent? Y'all need to know this. The highest exponent. So like 3 here would be my what? Starts with a D. Not that name. I'm gonna have you think about it, and then I'm gonna have you answer after we're done. So I start with the highest exponent, which is the 3. What's 1 plus 1? 2. And we don't add the exponents, we keep them. 2x to the third. When I'm done, I cross it out. Then I go to my next highest exponent, which is 2. 2x squared minus 2x squared. What's 2 minus 2? 0. So they just cross out. You don't even need to write 0x squared. Then we have negative 1x. Is there anything to combine that one with? Nope. So I just write it down. Minus 1x. And then what's the last one? Minus 6. That's your answer. Now, if you do not remember vocabulary, I would write this down. What is this term? Which one is your constant? Good. I like that you didn't drop a negative. Remember, the constant magnet number by itself. These vocabulary terms will be on there. Like they'll be like, which one's the constant? What's the highest exponent called? Did anyone come up with it? Degree. Yes. So I just remember if it's like it's going to be 82 degrees today, that little degree sign reminds me, oh yeah, it looks like a little exponent. It's your highest exponent. What is this number? It's your leading what? Coefficient. So your leading coefficient is with your degree. This would just be a coefficient. Remember, like co-teaching, co-worker, with a variable. How many terms are there? 3 terms. What's that called? Trinomial. What if there were 2 terms? 1 term? Monomial. If you don't remember any of that, write it on your piece of paper. If you do, then cool. You don't need it. Any questions on this? This is like crash course. Any questions on this? All right, last one I'm going to go over for right now. I'm going to erase all this. Is multiplying. What are the 3 ways we can multiply polynomials? The box method. What's another one? Starts with F. Factors is the opposite of it, actually. It's FO. Foil and distributive property. Remember that? So, do I need you to know all 3? Do I need you to know all 3? No. Pick one that you want to use and stick to it. So, we know that area means multiplication. We know that we're using, when they say area, we're multiplying length times width. Remember that. So when I'm doing that, here's my 2 things. Now, I'm not finding the perimeter. That's why you got to pay attention. They want the area. Most of y'all use the box method, so let's use the box method to solve this one. If you don't remember this, I would write it down. So it's 4x plus 1 times 2x minus 3. That's what we're doing there. So what do I put at the top of this box right here? 4x. What do I put right here? Plus 1. Angel, put it up. What about right here? Minus 3. Then I multiply. So what's 2 times 4? 8. And what's x times x? X squared. I would definitely write this down if you guys aren't like shouting this out and don't really know it. I would definitely write multiplying all. So we know multiplying's area. Or it could take product, like this one. This would be the same thing. What's 1 times 2x? 2x. And be careful, because in this class, I remember a lot of y'all started adding these. Like you would do 1 plus 2x and get 3x or something. Make sure we're always multiplying. What's 4x times negative 3? Because make sure it's negative 12x and negative 3 times 1. Then I write down all the terms in the boxes right here. Then what do I do? Add like terms. So which ones can I add? What's 2 minus 12? Negative 10, right? Then I add the other ones. So my answer, oh, it's okay. That's my answer for that one. What's the degree? What's the constant? Oh, here, everyone, Brandon, I'm not an answer. What's the constant? Constant. Negative 3. What's the leading coefficient? How many terms are there? What's that called? What's the middle coefficient? Negative 1. Negative 10. What's the variable? Good. Y'all go with that? Cool. So, at this point, I'm going to do conversions with you, and then I'm going to have you practice the rest of the ones you didn't do. Right here, this is missing on your sheet. See where the house is? Underneath it says 14x plus 13. That is not on your sheet, so write it in. It's missing on your sheet. This part right here, on that question right there, write that in. It's missing on your sheet. So make sure to write that on your little house. At the very bottom, see it's cut off. So on the house one right there, it's cut off, that bottom one. So write that. It's the one that's open. It's 14x plus 13. All right. Last one I'm going to do is conversions, and that's kind of the one we struggle with. There may be one conversion question. It's not going to be too many, to be honest. I'm going to do number 9 with you. So go back to the page before, and we're going over number 9. I know it's a lot of me talking, but the more homework you do and tell me which ones you know, which ones you don't know, the less me there is talking. So this says a rectangle has a length. So first of all, it says a rectangle. What should I draw on my paper? A rectangle, right? So first I'm going to draw a rectangle, no matter what. All right, has a length of 12 meters and a width of 400 centimeters. So a length of 12 meters and a width of 400 centimeters. What is the perimeter in centimeters of the rectangle? What does perimeter mean? Add up all the sides, right? So first I need to figure out, I need to get them all in centimeters. Which one's not in centimeters? 12 meters. So first, when I'm doing conversions, I start with what I need to convert. I need to convert 12 meters. So that's my starting value. So I start with, what do I need to convert? 12 meters. Then I need to know, okay, what is the conversion? How many centimeters are in a meter? What does centi mean? What is a century? How many years? 100. So how many centimeters are in 1 meter? 100. That's just something you need to know. I just remember century sounds like centimeters. They have the same centi means 100. So now remember, meters is at the top. Where's meters now? The bottom. So 1 meter equals 100 centimeters. Now let's make sure I got the right unit. So I cross out meters and I have centimeters. That's what I want. Then what do? I multiply across. So what's 12 times 100? Yep. And then 1 times 1? 1. So this means that this 12 meters I'm going to cross out. It is 1,200 centimeters. If this side's 1,200 centimeters, what's this side going to be? And if that side's 400, what's this side going to be? How do I find the perimeter? Add them all up. When do I multiply the length times width? What's that called? What would it ask me to do? Area. Remember, this is a crash course, but you already learned this. Let me know what you guys end up getting when you add all 4 sides up. What do you get? D. D. Going off. Does that make sense? Cool. All right. So right now, I want you to think about the one lesson. If you did not do your homework right now, I want you to think of the one lesson like, hey, I definitely want to make sure I know this. And so what I want you to do is I want you to choose from these 2 pages. Here's some of them. So here's like coefficient. So if it's vocabulary, I would do the ones in this top section. If it's polynomials, I would do the page right here. And then the front page is conversions, and we already did radicals. If you still want practice with radicals, on page 1, the first question right here. This one, see how this looks right here? See how it says P of X equals that and Q of X equals that? It says, what is P of X? Do you see how they're trying to make you like think this is some weird contraption little question? This is exactly, it's just saying take this minus this. It's just subtracting polynomials. They're just trying to make it more complicated. Same with this, they're saying what's the difference? What does difference mean? What does it mean? Add, subtract, right? So they're saying take those and subtract them. And then that first question on your packet, the very first question is a radicals question. So I want you to decide which questions on that packet do you want to try out, and I'm going to come around and stamp just to make sure you got the right answers. These are if this is the radicals question, and this is more subtracting polynomials. So I would only do those if you know the other 2 pages. Your homework, which I'm going to have you take at the beginning of next class right away. If you're good with this and you're like, Miss K, this is simple, I already got the right answers, which I don't think any of you were, you can start your homework, which was unit 2, which is equations, inequalities, all that. But I would work on this for a little bit. You guys have like, I think it's an extended bell. I think it's extended bell today. Because there's testing today or something. On miles.